AI agents are everywhere, and at the heart of agents are tool calls. That's what makes an agent an agent. Anthropic just released advanced tool use to their developer platform, and I'm going to walk you through exactly what they did and why it's important. Everyone wants their LLM to do all the things: hit your CRM, check your inventory, update Jira, ping your team on Slack. It's great in theory, but in practice, when you try to cram thousands of tool definitions into an LLM all at once, it breaks. You're eating up its entire context window, basically its working memory, and there's nothing left for the actual task at hand. Everything gets slow, expensive, and honestly kind of dumb. The tool call accuracy goes down, and you're using way more tokens than you should be. So today I'm going to walk you through 3 new advanced tool use features Anthropic just released to fix this. Now, the first one is the tool use tool, which they created. The second is programmatic tool calling. And the third is tool use examples. And so I'm going to start with the first one, tool use tool. So the way that agents work is you basically have an LLM that makes tool calls to solve an objective. So let's say the objective is a customer service agent. The role is to be a helpful, accurate, efficient frontline support agent, and it's to answer questions that people have. What's going to happen is somebody messages the LLM. It basically decides which of the tools that it's given to run. So you can see in the prompt that we explicitly tell it what tools it has access to. So it has get customer profile, get order status, modify order, issue refund, and create support ticket. So we have to give it basically a description of what each of those tools does, along with how to actually call that tool. So when a request comes in, it decides which tool to run. It runs the tool, it gets feedback from the tool, and it runs the prompt again. And it basically goes in a loop until it answers the question or it achieves its objective. So this is like traditional tool use. So this prompt in this case is 2,700 tokens. With the tool use tool, you don't actually have to give it all the tool definitions in the prompt itself. And so that greatly reduces the amount of tokens that you need to use to run the LLM. And that's kind of what this looks like. So this architecture, you can see it's the same information about the agent, but you can see this prompt is only 903 tokens. And the main reason for that is because we could remove all of the tool use definitions. The way that it works instead is when it decides to run a tool, it actually runs the tool use tool to pull what the most relevant tool is for the current task. So you can see here's a list of the tools. It's going to run a search. It's going to pick the right tool to run for that particular loop. And then it's going to run the tool call, get the feedback, send it back to the prompt, go in a loop. So there's basically an intermediary step where it searches for the right tool to use before it runs a tool. And this greatly reduces the number of tokens that are required. As you can see here again, we had to define all the tools in the original prompt, which was about 2,700 tokens, but the new prompt is only 903 tokens. And you can see that when you run it in a loop, it's going to take a lot more tokens than that, but it's going to be way less than what we had originally. And this is one of the main methods that advanced tool use reduces the number of tokens required to actually run an agent. The second part of advanced tool use is programmatic tool calling. So the problem that programmatic tool calling is trying to solve is twofold. Number one, let's say, for example, you are dumping a log file of errors from your terminal into Claude to try to solve a problem, and it's a 10 megabyte file. The problem is that you're using up way more tokens than you should be. It's going to be using a ton of tokens just to look at and ingest that log file, and then it's going to use a bunch of tokens to think through what are the problems in that log file. When in reality, what you really need is just to summarize what are the most important issues in that log file, and that's what it needs to know. It doesn't need to know every single detail about the log file. The second problem is that let's say you have to run like 5 different tool calls. Every single one is going to require a separate inference pass of Claude to basically figure out like what to do. So every time it runs a tool call, it's going to run the tool, figure out what's going on with Claude, synthesize the information, and then run the second tool call. And that's going to require another inference pass, another separate run with Claude. And each one of these is going to take up a bunch of tokens. Both of these combined will blow up the number of tokens that are required to run a task. So programmatic tool calling is another way to reduce the number of tokens that are required to do this. And I'll show you how it works. All right, so the best way to understand this is through an example. The example that we're going to start with is which team members exceeded their Q3 travel budget. So you're a business, you want to go through all of your team members for a particular department. You want to figure out who spent more than they should have. The available tool calls for this agent would be get team members, return a list of team members for a particular department, get expenses. So for each specific user and for a specific quarter, you want to return all of the expenses for that person, and get budget by level. So like how much should junior employees be spending versus senior employees, that sort of thing. So in the traditional approach, what would happen is basically the LLM would decide to run the first tool call, which is get all the team members. So let's say, for example, in this case, there's 5 different team members in this particular department. So it'd pull a list of those 5 team members. For each of those team members, it would need to run a get expenses tool call where it's going to pull all the expenses for this person for, let's say, Q4. We have 1, 2, 3, 4, 5, 6 tool calls. For each of the get expenses tool calls, we're going to return a list of what what were the expenses. So Uber, flights. So you would get a giant list back for each of these people. And what would happen in the traditional approach is this giant list for each person would get fed into Claude. And so you would end up with a list. Let's say each person's list is 20 lines long. So you would have a list of 20 times 5, which is 100 items long. You would send that to Claude, and then it would process the results, and you would get the result as the output. So there's a lot of context being put into Claude where it doesn't necessarily need to have all that context just to figure out who spent more than they should have. So in the advanced use case, it's a very similar process, but you can see that I've basically put it in a gray box. And the reason is because this is all happening via code. And so none of what's happening inside of this gray box is being sent to Claude. Let me show you kind of what's happening. So we start again with the get team members tool call. We'll return the 5 team members. For each of those team members, we'll run the get expenses tool call. We'll get a list of expenses for each person. Each of these is 20 lines long. What's going to happen is we have code will only return the people who actually went above the expense limit. So it's going to run the get budget by level tool call. So it knows like, hey, for like these 3 team members, these are junior employees, so their budget is only $600 versus these people are senior employees, so their budgets are $800. So it's going to run the code and it's going to say, okay, well, it's going to go through each of these expenses and figure out, okay, is this person over budget or under budget? Same thing for this person, this person, this person, this person. Let's say only 2 of them went over budget. You can basically tell it to output a JSON with the person's user ID, how much over budget they were, and what level employee they are. So it's a JSON object. So it'll return basically 2 JSON objects with 3 fields each to Claude, which will then basically synthesize the output into the result. So you can see in Claude, it was only given 2 JSON objects where the result was already in them. How much over budget were these people, and who were those people who were over budget? If they weren't over budget, they weren't even sent to Claude, so it didn't even have to process that. As you can see, this is much more efficient and it's actually faster. And so this is kind of what the code looks like. So you can see in step 1, we get the team members. We fetch the budget for those team members, which is happening here. So this happens in parallel. So it's running this get budget by level tool call in parallel for all the different budgets. It makes a dictionary where each level gets the budget as the key. It fetches all the expenses in parallel. So it's going to run, in our case, 5 people. So it's going to run the get expenses tool call for all 5 people in parallel. And then this is kind of where the magic is happening in this part, where it's only returning people who exceeded their budget. So you can see here what it's doing is for every member and every expense that it returned from the tool calls, it's going to get the budget for this member's level. It's going to return a sum of what this person spent. And if this person spent more than their budget, it'll return the JSON object with their name, how much they spent, and what they were supposed to spend up to. And that'll be sent to Claude to synthesize. So you can see it was able to filter out 3 people, and it only returned 3 different lines in the JSON object to Claude. Whereas in the traditional approach, it had to send 20 line items for each person all to Claude for it to synthesize. It saved a ton of context and it was more accurate too. So this example kind of shows you the difference in the way that the traditional tool calling approach would work versus the programmatic tool calling approach. All right, so the third part to advanced tool use is tool use examples. And this will probably make a lot of intuitive sense to you guys. So what's going on here? One of the problems with tool calling is, let's say, for example, we have these like customer support tickets that we have to make. And so we want the output of our tool call to be in a specific format. So we give it the schema for what the output's going to be in this case. So we have name, input schema, we have all these different tags, these nested properties. We have a bunch of information here. We have a few problems though. Number 1, we don't know what format each of the fields should be in. So sure, we have a due date field here, but we don't know what format that due date is. This is just JSON. So do we use 2024-1106? November 6, 2024? Do we use a timestamp? For IDs, for example, if we have a UUID somewhere, is it supposed to be in a format like this where we have some letters dash a bunch of numbers? Or is it just a bunch of numbers? For the nested structure usage, how do we know when certain fields are optional or when they're not optional? And then finally, how do we know when certain fields are correlated to each other? The solution is to give the LLM some example tool calls. And that makes a lot of sense. So here's an example tool call for creating a ticket. We get the title, priority, we have some labels, we have the ID, name, email, we have the due date, and blah, blah, blah. We have a bunch of information here. So what could we learn from this? Or what could the LLM learn from this example? We could learn that the dates are going going to be year, month, day, 2024, 1106. We know that the IDs are going to be in the format where we have USR dash a bunch of numbers. We know how to make a nested object like the reporter here. We know how some of these optional parameters are correlated. So Claude basically found that giving tool use examples to your LLM will increase tool call accuracy from 72% to 90% on complex parameter handling. And so that's a pretty amazing result just by giving it examples of how to run a tool call. But that makes a lot of intuitive sense, and that's kind of the third piece of advanced tool use. So yeah, let me know if you guys have any questions. My name is Basil, and this is how Anthropic has implemented advanced tool use, which is currently in beta for Max users and Pro users, I think.